Hello students, last time we have discussed about molecularity and now we are going to discuss about activation energy. According to collision theory, a reaction takes place because the reactant molecules collide with each other. The minimum energy which the colliding molecules must have in order that the collision between them may be effective is called threshold energy. The minimum extra amount of energy absorbed by the reactant molecules so that their energy becomes equal to threshold value is called activation energy, and threshold energy is equal to activation energy plus energy possessed by reactant. Now, after activation energy, temperature dependence of the rate of a reaction. For a chemical reaction with rise in temperature by 10 degrees Celsius, the rate constant is nearly doubled. Now, Arrhenius equation. Quantitatively, the temperature dependence of the rate of the chemical reaction can be explained by Arrhenius equation. K is equal to A e raised to minus EA upon RT, where A is the Arrhenius factor or frequency, R is gas constant, and EA is activation energy measured in joule per mole. The factor E raised to EA upon RT corresponds to fraction of the rate of reaction that have kinetic energy greater than EA. After this topic, now effect of catalyst. A catalyst is the substance which alters the rate of a reaction without itself undergoing any permanent chemical change. As for example, in the reaction of KClO3, MnO2 is used and KCl plus oxygen is obtained. Action of catalyst. According to intermediate complex theory, reactants first combine with catalyst to form intermediate complex which then decomposes the form the products and regenerating the catalyst. Now, collision theory of chemical reaction. According to this theory, the reactant molecules assumed to be hard spheres and reaction is positively occurs when molecules collide with each other. Rate of the reaction depends on the number of effective collisions which in turn depends on energy factor. Colliding molecules must have energy greater than threshold energy. Now, important formulas of this chapter. If the reaction is then instantaneous rate is equal to minus 1 upon A delta A upon delta t, which is equal to minus 1 upon B delta B upon dt. This is for reactant, and for product 1 upon C dC upon dt is equal to 1 upon d delta t upon delta t. This is formula for instantaneous rate. Now, average overall rate minus 1 upon A delta A upon delta t is equal to minus 1 upon B delta B upon delta t is equal to 1 upon C delta C upon delta t is equal to 1 upon D delta D upon delta t. This is formula of average overall rate. Now, Arrhenius equation K is equal to A E raised to minus EA upon RT.